and things that depart from that pattern. When you talk about your scatter plot, there are three things that they're looking for, kind of like the SOCs when they're talking about your density curve. In a scatter plot, they're looking for the direction, so you're going to use the word positive or negative. For the form, they're going to be looking for whether it's linear or curved. And the strength is strong and weak, and I actually add the word average, and I'll talk about that shortly. Noting your outliers, individual data points can strongly change what your correlation is going to be, which we're going to talk about later. So it's really important to talk about outliers. When you're talking about positive and negative association, this word association is a word that's used quite frequently in statistics. You're going to use that word a lot in this class. A positive association is one where the overall trend of your graph is going up. So if I look at a scatter plot and I see a bunch of dots, and it looks like the general shape of that is going up, that's called a positive association. On the other hand, if I'm looking at a graph and I check out the dots on that graph, and it looks like the overall pattern is going down, that's called a negative association. When I took statistics at the University of Minnesota for my master's program, we had to memorize this formula and use it in our calculator. You're not going to have to do that. This is to find your correlation coefficient. So the next big thing that we're going to be talking about in here is correlation. And I'm going to show you how to do that on your calculator so you don't have to worry about it. They use the letter R to talk about correlation. Each X and Y sub I is talking about the individual data points, like X1, Y1, X2, Y2, that kind of thing. So it's each of the individual data points. X bar is your mean of all those data points in that one list. Even if it's list 2, where that would be the explanatory variable, and we know that's the Y, your calculator will still output it as X bar. So don't get fooled by that. They can't display a Y bar, so they just keep using the X. Your SX is your standard deviation, and R is your correlation. So what I'm going to do is I'm going to show you how to find correlation on your calculator right now. You might want to write down these directions. So the first thing that you want to do is when you're in your calculator, you want to go second 0. And it brings you to the catalog. So you might want to write that down, second 0.
Are these the instructions at the bottom of the page?
Probably. You can take a look. If they are, then that's good. And then I'm going to go to the letter D for diagnostics. So the letter D would be alpha, and then wherever the D is, which looks like to me is above where it says X minus 1. That worked out well. Second. Nope, that's not what I wanted. Alpha D. There we go. And then I'm going to arrow down. And I'm looking for a phrase that says diagnostic on. Oh, passed it. Now, if you don't reset your calculator after we do this, you should never have to do this again. But just in case, you know how. So you go enter twice, enter, enter. It'll say done. Now here's what will happen for you if you want after you turn your diagnostic on. For example, we already have our two lists, right? We drew our scatter plot. So if I go to graph, here's my graph of my scatter plot from before. If I want to see what the correlation is, I could go stat, calc, and I could go down to my linear regression, thinking, of course, that this may be a linear relationship, hit enter twice, and because it's defaulted to list 1 and list 2, it'll take that information, and down below at the very bottom you'll see your R. You'll notice that it's negative 0.7433. And this is your correlation. This means that there is a strong negative linear association between the cans of beer drank, or whatever data we had in there. Was it the long jump? Okay, but between the seconds and the distance. Strong negative linear association. So going back to our notes, what I want to tell you is that you're going to have three phrases. So whenever you're talking about whether or not it's positive or negative, that's really easy to see. It's either a negative sign or it's not, so that's positive or negative. If you're looking at decimals and you talk about what's strong and what's weak and what's average, I usually talk about the ones that are strong as the 0.9s, the 0.8s, and the 0.7s. I talk about the ones that are average as the 0.6s, the 0.5s, and the 0.4s. And then the weaks, I talk about as the 0.3s, the 0.2s, the 0.1s, and then obviously anything with a 0 is also weak. Okay, so in this next slide, there's really not any math involved as far as what we're going to do in our class, but there's just some information. So first of all, correlation doesn't make a distinction between explanatory and response. It would not have mattered which one you picked to be your explanatory or response. The correlation is going to be the same. It makes, let's see, because R uses the standard values, R doesn't change no matter what the units of measure are. Correlation does not have a unit. There are no units with correlation. Positive R values means a positive association. Negative R values is a negative association. Correlation needs both variables to be quantitative. That's what I talked about earlier. You can't use like hair color. And your correlation will always fall between -1 and 1. No matter whether it's positive or negative, the closer you are to the absolute value of 1, the stronger the association between the two things. And correlation measures the strength of linear relationships. So if we had a curved situation, correlation doesn't do a very good job. Like the mean and standard deviation, it's not resistant. That's very important. So correlation, not resistant. Down below, we have some examples of scatter plots. And so if we were going to talk about the correlation of each of these scatter plots, it might be helpful to kind of see what we think these are. So as you look at this one, there doesn't seem to be any general pattern whatsoever. The correlation here probably is somewhere close to maybe, I don't know, 0.1 maybe. It's very weak no matter what it might be. Maybe it's even negative, I don't know. In the second one going across, it looks like there's an overall general pattern going down, but it doesn't look like it's very strong. The stronger the association between the two variables, the tighter the dots will be to a line. So this one, although the pattern seems to be going down, seems to be somewhat weak. So maybe, just as an example, this might be a correlation -0.3. In the third one, the overall pattern seems to be going up. It's a little bit tighter than the one that was in the middle, but still not very strong. So maybe this is an average association. Maybe, for example, a correlation of roughly 0.5. The fourth graph on the bottom left, the dots are even tighter than they were before. So this is a stronger association than the light blue one. And perhaps this one, although being negative, would be an association, or in this specific example, a correlation maybe somewhere around -0.7. The association getting tighter. In the fifth graph, going up, I know that my correlation is positive. Again, probably a little bit tighter than the previous one. I might say that the association is roughly 0.8 positive, meaning tighter than before, still not perfect. And then in the last one, I see that I'm going down. All of these dots are super close to being on a line. This is a very strong negative linear association. I probably would give that a value maybe somewhere around R equals -0.95 or something. Questions on correlation and association? Association is the general term. Correlation is specific to a linear graph and the tightness of the dots to a line. Okay, in our last example,